So welcome back to the Institute of Refrigeration, Beyond Refrigeration, the Tip of the Iceberg podcast. And our episode today, we're going to be talking about achieving best system performance and looking at things like design issues, service and maintenance, and how they interplay and how they can really help customers get the best out of the refrigeration equipment that they're using. And I'm joined by two people who are really active in the Institute of Refrigeration in lots of different groups who are very influential in the industry. I've got Lisa-Jayne Cook and I've got Ian Fisher. So thanks both of you for taking time out on what is today is a very hot day. So I know hot days mean industry very busy. But in the meantime, what I'll do is I'll get you started by introducing yourself and just ask you a little question to get us started. What does best system performance mean to you? You know, you are both really practical, hands-on engineers. When I talk about achieving the best system performance, what does that mean? And then we'll go into a discussion. Let's start perhaps with Lisa-Jayne. Do you want to kick off on that? Introduce yourself and tell us about system performance.
So I'm Lisa-Jayne Cook and I work with GEA in their heating and refrigeration technologies, actually in their service division. I've been with them just for over a year now. And prior to that, I've worked with companies doing complete system design as well as air side product design. So I've got quite a bit of knowledge on that side. For me, I suppose best system performance is running the system at a level where it meets the customer's expectations, so it's delivering the duty they want, but also using the very latest technology and making sure that it's maintained and up to date so that we're not using more energy than is necessary really to meet their expectations.
So performance is about energy, but also delivering cooling, yeah?
Yeah.
Your point of view. Okay, thanks very much. And then passing over then to Ian. Is anything different or are we all going to agree to kick off?
Hi there, yeah. So it's Ian Fisher. I'm Technical Sales Director at Mattair. And I've been doing air conditioning and refrigeration for over 34 years now. But the main core work that we're doing now is air conditioning, ventilation, heat pumps, and also a lot of ventilation. So yeah, I'd just like to, just re-clarify just exactly what Lisa said. It's all about performance. And for me, it's being run as designed, because what you tend to find is a lot of people is they can have a system and their expectations are different from designer. So maybe that information not being transferred down. I'll chuck one out there. For instance, you buy an air conditioning unit and the remote controller says 16 to 31 degrees. You haven't got much chance at all getting it to 16 or 31. More realistically, you're in 19 to 23. Anything outside of that, and you're pushing your luck and your energy bill up. So I think it's about designing a system, letting somebody know what it's designed to achieve, and then the end user knowing that and working within its parameters.
That's the sort of interesting thing for Beyond Refrigeration. We're trying to work at encouraging the end user, the operator, to understand the systems. And I think you both mentioned about their needs, because for a lot of people, air conditioning and refrigeration systems, they call them black boxes. They don't really understand them. They don't know what's going on. They don't understand how they should set them. They don't understand if there are changes to their system, what they need to do. Is this about the interplay between design, service and maintenance and operation then?
Yeah, I think it is. I think when it comes down to refrigeration, there's a lot more design, or everything's designed straight away. But when you get to air conditioning, especially on smaller systems, there's always an element of guesswork. You kind of see that, because I'm also a TM44 assessor, and you can kind of see that when you're going around looking in the building that somebody's guessed what size that unit should be. And it does happen.
And Lisa-Jayne, are you more refrigeration or are you also included in ventilation, air conditioning side of things?
I don't really touch on ventilation and air conditioning. And I think actually what Ian's saying is really valid for what he's looking at. I think from a refrigeration point of view, you really need to know your application, you need to know your client, and you need to know their direction with their business over the next year or so. And, we do often find, as Ian said, sometimes you go in places there's a surprise. So, somebody's moved a wall in a cold store, they've moved a rack, and it means it is actually affecting the performance of their system. So you need that regular contact with your customer to be able to make sure that the system is running to their expectations. And I get what Ian's saying about design, but refrigeration is changing all the time, as in the application and the customer's uses. We see quite frequently customers putting a new line in a factory and then thinking about the refrigeration afterwards. And that's really when you need to manage their expectations, but also try and get the system to run the way they need it to run. It's about supporting your customer.
And it seems actually there's quite a lot of overlap in between what people are doing as a matter of course in refrigeration, expecting that to be a long-term relationship where you work on continually adjusting and hopefully optimizing as well. And perhaps from what Ian's saying, some of the air conditioning in the past has been simply sell a unit and move on. So do you think that there is something that needs to be learned or picked up from the refrigeration side about the customer engagement and support in order to achieve that energy efficiency? Because you mentioned TM44, so that's the methodology for the building performance inspections that businesses need to undertake every 5 years, the larger ones.
It is, yeah. So as part of doing that, you get to have a look at your site, you look at the maintenance. In general, air conditioning maintenance is really, really good. You know, most of them are twice a year, which is mostly adequate. But what you do tend to find is the mass, you know, how people use them. I was looking at one the other day and I says, oh, how do you use it? Because I went in and it was freezing cold, and then I went back in that room later on and it was red hot, and it's just turned down to 16, it's run. Then when it gets too cold, it's just turned off again. So clearly that system's been designed and put in. The end user doesn't know how to use it, doesn't really know how to use handset, and just cranks it fully down or fully up for heating or cooling. I do think that it's a process that goes right through. The person that designs it needs to show what temperature is designed it to run at, and then when the installer goes there, he needs to know that, and then he needs to instruct the operator and how to use it. And I'm also a big fan of seasonal commissioning and things like that, whereas when it comes to learning the foot soldiers, so to speak, the service engineers that are out there servicing, if that information is on a sheet that this unit should be set, you know, at 23 degrees cooling or 19 degrees heating or anything like that, so they can inspect it, look at the time schedules, and then they can discuss that with the client. Say, you know, you're using it wrong. Put a thermometer on the wall, see what temperature it is before you make any adjustment to it. How can you set a temperature in the room when you don't actually even know what the temperature is? I know most modern systems now do tend to have a temperature sensor on there, displays what it is, but you still can't beat a thermometer at wall, because sometimes the controllers can be in a cupboard or quite far away from unit or area it serves or something like that.
And what about, is there remote monitoring though? Could they not look at that remotely, or are you looking at really quite small systems in quite small buildings?
Yeah, you could do. There's a lot of units that are connected to Wi-Fi these days, and it is relatively easy to do. But what you tend to find is that's okay in small businesses or domestic properties. But there's a lot of reservations about, you know, large buildings putting equipment on Wi-Fi, you know, because of the security risk. So I've only known a few that'll do it, and they generally do it through a 3G router. There is essential controllers for larger systems which can connect to BMSs, such as a large VRV. Then you could have a central control in a plant room, and then that can be dialed into remotely. So that kind of thing works.
So that's more in like offices and hotels and stuff like that. Yeah. And what about, so Lisa-Jayne, what about in your sector? Is there using a lot of remote monitoring to make sure the performance is what the design was for?
We do. So a lot of our clients, or a lot of the clients that I work with, are food based, so they're either manufacturing or storage, so actually the temperatures are critical. And I think again that's probably where some of the difference comes in, because air conditioning is more of a comfort thing in most cases, not always, but it is about comfort, whereas refrigeration, you know, if we're not meeting those temperatures, they might not meet their required levels for audits. They could have batches of products actually just thrown in the bin, and that's really a big problem for us. So yeah, we do remote monitor everything. We do a lot of checkings, like Ian said, you know, for them on the air conditioning maintenance is twice a year. We do look after air conditioning, and we do twice a year as well. But with our refrigeration plants, depending on size of the client, we could be there daily, weekly, some are monthly at the smaller sites, but a lot of them tend to be, we are on site daily. We are checking the system daily. We've got remote dial-in, so if something goes wrong at night, we can log in and have a look at their plant directly, and hopefully pre-diagnose some of the issues before we get to site as well.
So those inspections, are they mandatory? Like you know, Ian's talked about the building services side, where you have these 6 monthly or annual inspections which are required by law. There's nothing like that in the industrial side.
Well, under F-gas, we still do have to do the regular checks, and obviously that's determined by the size of the system. But a lot of what we do is related to actually just keeping the plant performing.
So it's about reliability. When they're doing the work that both of you are obviously customer facing, talking to a lot of people about their demands. So a lot of that is around, reliability and performance and things like that. How high up that agenda and those discussions is this whole issue of net zero? Are they talking to you about how can I reduce my energy use? What can I do beyond just energy to make sure that, I've got a plan, and how does that work for my cooling needs? Is that on their agenda at all?
Yeah, probably always. I'll bring it into conversation, about carbon saving, especially for air conditioning. Just want to shout it out there. One of the best technologies for heating and reducing carbon there is out there compared to a lot of others. But it's really rare for somebody to come to you and say, I want to reduce carbon, or I want to achieve net zero. You're normally spawning that conversation. And then if that fits their agenda, or they can use it as a tool to get that project over the line, then it will be used. But as of yet, no one's come to me with an actual plan or a carbon reduction that, that they want, something that they want to achieve.
So even with the energy prices going up, we're where we are at the moment, we're in June, and everyone's really concerned. I've heard about people talking about, 200% increases in their business energy costs. You're still struggling to have those conversations about what can we do to reduce our energy use for the air conditioning?
Yeah, I mean, there is a lot of that. But the other thing is about net zero and reducing carbon. It's about reducing carbon, which means using electric, which doesn't always mean it's the most energy efficient. As soon as I speak to somebody about net zero, they'll just kind of say, oh, what's payback on it? And say, well, there isn't a payback. You're going to be spending your money on new technology that's going to, use less carbon. And so, I mean, ironically, if you had gas heaters and then you switch to electric, just pure electric heaters, then you would reduce your carbon, but it's going to cost you a lot more money to run. If you switch it to a heat pump, then you would reduce your carbon and reduce your running costs. A heat pump might cost you £20,000 for your home. 10 electric heaters that cost you about £1,000 for your home. There is a payback, but it's a long way off. One of the questions what I do tend to ask is, do you want to reduce energy consumption? Do you want to reduce carbon, or do you want to reduce both? Which can be really difficult, but there is an initial spend in order to do that. Although when the equipment's running, it will cost less to run, but there is that initial outlay.
You're taking that initiative to raise the issue with them, and then they are listening. They might have struggled to make those decisions. It's all got to go up through finance and paybacks and things, but they are open to having the discussions at least, yeah? Yeah,
they are, yeah. A lot of people want to try and make you do some kind of impossible calculation, where you can give them, some kind of running cost based on their building. But one of the problems you get is if they've not been monitoring it to start with, you've got no data. So you can give them, some kind of calculation, but it's going to be rough at best.
Yes, you haven't got anything to compare. Yeah. And so then going back to the industrial system where the energy use, I guess, is even more critical. From your point of view, Lisa-Jayne, do you find that the customers have like a net zero strategy that they're working through?
Actually, a lot of our clients are quite big clients that already have their own net zero goals. But I'm sure we have discussed this before about the difficulty of retrofitting when you're not replacing complete plants. So there are things that we can do. And like Ian mentioned, like monitor, measure, review. So we can look at the running and we can adjust things. We can suggest modifications that will help to reduce both their energy and their carbon footprint. But the best results are always when we're consulted at the first stage. So when they're looking at building a new factory or new storage, warehouse, whatever it is that they're looking at, if they consult us right at the beginning and we work in collaboration with everybody else, so all the other different areas of engineering, and we can review the processes then and see where the waste is and actually where we can transfer energy. We have done a project recently where a wind turbine was installed on the site. So actually the site is net zero.
Wow.
Heat pumps, in much the same way that sort of Ian's saying that's the best option at the moment, is use a heat pump, reclaim the heat, move it off somewhere else, you might need to boost it, or maybe you just want to use it for wash down or something. There's so many different options for using that waste energy, but the best results definitely are at the outset of a project rather than trying to fix it later.
I kind of started this podcast thinking, we will talk about the difference between design and service and maintenance, and whether it's really the design that's more important or the service and maintenance. And now I'm starting to think, Lisa-Jayne, it's more about design. If you can actually go right from the beginning with the net zero as part of the design brief, you're going to get a much better result.
Yeah, but obviously the service side does really matter as well. If your system's short on gas, it's going to impact your energy usage. If your condensers are blocked up or your evaporators are iced up, all of these things are going to have a big impact on your energy use, which does have a knock-on effect. And then there's other things to consider as well. The indirect carbon issue, so the materials that you're using, or the refrigerant, or the glycols, there's so many different things that go into this as a whole, and things that you can change, but obviously none of it is cheap. And I think that's probably the biggest stumbling block that we have, is the client's budget versus their expectation.
And it's always that first cost investment. If they're prepared to invest, they'll get the long-term gain, but then you have to be prepared to live with a longer payoff than the one you're with at the moment.
I think a lot of people need to realise it's a journey as well. You don't just say, right, I'm going to do net zero and I'm going to do it next week, right, everybody. So, there's lots of other things you can do. You can have NZEB, which is net zero energy building. So you're not totally net zero. When you're on net zero, your complete supply chain and everything about you is that. But you can have a net zero energy building, which of course would be the one with the wind turbine. Or you can have, that might even be a negative energy building. And there's also a thing now where they're saying where you get a nearly net zero, as you're working towards it. So it's about making, strategic goals. And when people are designing, they need to be looking, designing it to work at that temperature. They know that, and then they know what the operation carbon of it is going to be. And it's about keeping it down. And for me, once it's in, it's keeping that operation down, because when you have a building or any kind of system, there's loads of people that are doing little bits about it, or little things that can interact with it. So when you're having a large building or some kind of mechanical fit out, there's somebody doing the heating, the ventilation, the BMS, and the thing is it's all got to work together. And what you can tend to find is when they're all commissioned, they can all be, they're all set to run, and then it's making sure that they're running uniform further down the line. You see a lot of things like, in winter, people don't like cold draft from grills. They'll turn the supply air temperature up, and then it's not a cold draft anymore. But then when summer comes, it's adding to the heating effect at building. And then that gets left, and then the air conditioning gets run flat out, and then somebody complains that they're in a draft. And then the air conditioning engineer goes out, there's nothing wrong with air conditioning, it's all working fine, which it is, but it's just not working in unison alongside the ventilation or maybe the heating system. So maintenance is important. When you're on a site and you're maintaining an item of plant, look at everything else that can affect it as well. Look at other settings. You're already in plant rooms and on roofs. Just have a look and see what's going off there.
Yeah, again, one of our Beyond Refrigeration themes is about working together. And that started off really because we knew that a lot of other organizations had a lot of net zero initiatives. And we thought, we'll bring them together and we'll share our knowledge. But actually, from your point of view, it's all the different trades, all the different engineering functions on the site also need to work together. You just can't have everyone doing their own thing. You have to look at each site as an integration, particularly if you've got those kind of objectives, which is beyond just getting it up and running.
And the other thing as well, we're obviously just coming out pandemic. And when COVID first came out, the first thing that everybody were told to do, we increased the ventilation. So up and down land, you've got loads of air handlers all running full tilt. So if you've got a day like today, where it's between 25 and 30 degrees, it's chucking it in. So I always said that, you've got to associate mechanical ventilation with an open window, because that's virtually what it is. You're bringing air in and you're letting it back out again. And it's trying to make that association that you've got to open and close window to an appropriate level. I know we've got to have good, clean air, and indoor air quality is important. But I do think a lot of buildings will be over-ventilating at this minute for the amount of people that are occupied, because a lot of them might have been set to 10 litres per second, and it's we actually want 20 now. better for COVID. And when in reality, if there were 200 people in that office and now there's only 50, you've actually, without even adjusting the ventilation, you'd be providing 40 litres a second per person. I do think, things like that need to be reviewed.
Yeah, I mean, we always talk about RACHP, refrigeration, air conditioning, and heat pumps, but you're moving us more into the American style of HVAC, or it's heating, ventilation, air conditioning, and refrigeration, because the ventilation is critical to making everything else work. I guess for Lisa-Jayne and your business, ventilation, it doesn't come up, or does it still, because you've got to move the air around?
It does, because we do have some production areas that have to be positive pressure, so like the high care areas. So we do get involved in ventilation. It is important in food production as well.
I was going to ask you both actually to think of an example of where customers are really getting it right. At the moment, it's groundbreaking, and maybe say a little bit about why that would be.
Yeah, well, I think actually that project, I think that they did get that right, because they thought about their requirements. So what they wanted to do with that factory, how they wanted that factory to be set up. And they already had that net zero in their sites for that factory. So they consulted several different areas of engineering from the off. So they looked at where perhaps, like I say, we are wasting energy, and refrigeration is a really obvious place. And they involved those people right at the beginning of the project. So we all had to get together and discuss how we could utilise any of the waste within the system. And actually on that system, they don't have a gas boiler either, because they are using the heat pump. So we've got the heat pump, they're pasteurising the product. And then, like I say, that at the end, they were looking at, how can we be just that little bit greener? And that's where the wind turbine came in. But like I say, I do think they've got that very right. And that is a very good project to look at, because it was considered right from the off. And I guess also the other part of it that's really important, like we spoke about before, about the sort of capital investment, is that they'd already looked at other systems and realised how much they would actually have to spend. Quite often a sticking point, isn't it? Because people have this idea of net zero, and we know it's expensive. To do the right thing isn't cheap. And we can work with the customer and use that as a jumping up point so that we can tailor it to suit both their financial needs and their expectations
on these things. So there is some trade-off between the first cost and the running costs, which is where we're trying to get people to look at the future, because that's kind of what we have to look at. There is the cost of not doing it, if you like, as well, that needs to be considered. So Ian, have you got any projects you can think of?
Yeah, I've got one in particular. It's a long ongoing project, and it's for a charity, and it's a church conversion, and they've kind of got it right, but unintentionally, it's going to be net zero, but that weren't the intention. They just wanted an efficient building. So the old system was stripped out, and then we were invited in because they were getting prices for new heating systems, and we were actually invited in by a heating company just to look at the ventilation. So we're having a look at it. They were thinking about putting hydrogen boilers in, and they go, why don't you go for heat pumps instead? And then they said, that could be really expensive. We've been told we can't have one big enough. So I goes, you got to think hybrid. So what we proposed we're going to have air-to-air heat pumps, aka air conditioning, because that's the new modern word for it. And so in your main halls in your office areas, you'd have your air-to-air heat pumps. It's not a church now; it's a charity, and it's been converted as a food bank. And I said, if you go for air-to-air heat pumps in your main halls, it'll help keep your food cool as well if you get chocolate deliveries and things like that in summer. And then in your corridors and your toilets, you could have a traditional air-to-water heat pump that will do your hot water and some radiators. Because obviously you've got to put some heating everywhere, and it's a bit too extravagant to put air-to-air heat pumps in toilets and corridors. So we did some calculations on it, and then they let me know that they were doing solar as well. They're having 10 kilowatts of solar. So I calculated the maximum input that all the air conditioning, the heat pumps could do, and that'd be 14 kilowatts if everything running full tilt. But it won't, because if it hovers on inverters, once everything's up to temperature, it's always going to be less. So we're still waiting for some run data from that building because it's not been running that long because it was quite a long project to do. So now they've got a system, they've got 10 kilowatts of solar, which will power the air-to-air and the air-to-water heat pumps. And also they can keep their operational carbon right down because everything's on the spot heating. In all the areas, they can just, in winter, they could just keep it trimmed at 16. In areas where they're occupied, they could just put it up. So when you have a traditional system like a boiler, you end up with a massive, you've got to fire all the plant if you just want a couple of spaces warming up. So I'm really excited about that because when we get some data there, I'm fairly confident that that's going to be a net zero energy building.
So learning for customers that on that one is, whilst you said it was almost by mistake, it seems to be much more about listen to the experts, that you can go in with an idea, you want to do something, but actually when you get the experts in front of you and they explain what might be possible, then you can achieve a bit more by not having a fixed idea of always doing it the same way.
I mean, I told them that, and I suppose, I think it's being confident about what you're proposing, and you could see it just makes sense. So they're over the moon with it.
It's a couple of really quite nice learning, or two quite different examples of one where people really know what they want to achieve from the outset, and the other one where they didn't quite know, but they're going to get something really great because they looked at the data and they looked at the options available to them rather than just going down one path. So as a whole industry, looking at the bigger picture, what do you think the things are that people get wrong, that they really need to think about in order to get us much further down the road of getting towards the net zero? So not the detail, but the big picture of, if you had to give some advice to, I don't know, a government person who is putting a new strategy in for net zero refrigeration, what would be the sort of top of your list to say to advise those buyers?
Well, that's a good one.
That is a really hard question, isn't it? Because we're sitting on one side and they're sitting on another. I guess probably the biggest issue or the stumbling point and where people start to get things wrong is to not actually understand what's available. So we need to do some education as an industry. I think, you don't know what you don't know, and it's really hard to actually say this is the direction we should be going in if you're not aware of everything. So as an industry, I think we need to do exactly what we're doing now, but we just need to keep pushing with this to educate people, so that hopefully when people get to that point, whether it be the government, designers, business owners, at least they've got a basic knowledge of, the possibilities. I think that's probably the best way forward.
Yeah, I think also as well.
Yeah, that makes perfect sense. We've got that in our thing about understanding the new technologies and getting some briefs on what's going on. Particularly heat pumps is a great example where there's so many different types of heat pumps and people just are saying they're all the same. Whereas, it's understanding the idea of where they do work and where they can get the savings and where they can't. So getting a better understanding of the technology is a good pointer. Ian, have you any thoughts on that one?
I think it's same. It's making people aware of what's out there, and then also with a view of what's best for being put in that building. But I also think that they need to be monitoring what they've got now, so they've got a starting point. Because a lot of people don't have monitoring, and then they want to see all these savings, and it's hard to show anybody afterwards if they've got nothing to refer to, because it's just numbers. And I also think I know people have talked about this in past, that when buildings are rated, it'd be good if we smart buildings. So your building's this side, it's got that many people in, and I'm using X amount of energy. And then if all buildings data from smart meters were all collated together and you had a building type, then I know you have it on decks where typically it'd be this and typically it'd be that, but wouldn't it be good to look at a building where you could log on somewhere live and see how much a building like yours is using right now? You'd have the really good ones and you'd have the really, really bad ones. And if you're only really bad, that can help make your decision. Then you can look at what, in order to know what good looks like, you've also got to know what bad looks like. So if that can be seen, and that can help people make changes, because they can truly see what kind of savings they can achieve. So everybody understands how much it costs to run an house, but it's really difficult to understand how much it costs to run a building. But the building next door, when you look at their data or shared data for the buildings like that, they've used half of mine. What have they done? And then you can see how much money you could save, and it'd be more tangible for somebody to spend large amounts of money if they know they could save on their energy bills. So I just think building needs to be smarter and data needs to be shared.
Yeah, definitely. Because we're used to getting smart meters in our house now. So people are used to looking at energy. I know it's a lot simpler, but we are thinking much more about that management of our energy rather than just taking it for granted. So we've got two really good ideas. One is the knowledge and the other is the management. These are actually, reasonably simple concepts, but to get those into a place where you've got those benchmarks, where you've got the technology briefs and things like that is a challenge for all of us. I think this whole net zero thing is not just about buying the right technology and putting in, but also communicating everything properly. And we're running out of time now. I was going to go on to a little bit about people and skills, but I think we're just going to say that we've got two really skilled people here who demonstrate there are people in our industry who have really good knowledge of what's going on, what possible solutions are out there, case studies, what goes wrong, what goes right. So we have to make sure that we're doing our best as a group to get the information out there, to let them know that there are experts there that can help them make some progress towards those net zero initiatives. It's not going to happen, and no one company is going to be able to do it on their own, is it? They all need suppliers. They all need everybody to work together, and that's kind of where we started with the thing. So, any closing comments? Thank you both really a great deal for sharing your expertise with us.
I suppose for me, the only sort of thing you mentioned, obviously, that there's a public misconception about heat pumps not actually being any good and that they don't work, and there is a lot of negative press. So I think that we as an industry, again, we need to really engage with the media, and we need to demonstrate the technology to the media, because I think if we can stand here all the time and share this message amongst ourselves, but until we actually reach, essentially on the level that Ian's sort of talking about as well, homeowners, we've got 600,000 heat pumps to install in the next few years, but actually people aren't going to buy into that technology if they keep reading that it doesn't work. So I think actually, as a collective, we've got a lot of work to do here to change that really negative view, because heat pumps are the way forward. They're the technology that we've got now. And it does work, despite the fact that people say that they don't work, or they're not very good, or they're really expensive to run. So I think, as a group, I'd really like to see us all working towards changing that public image.
Yeah, that's another big task to do, but one that people are sort of chipping away at. Ian, your final comments?
Yeah, I think Lisa pretty much nailed it on that. It's just getting awareness of technology, and also as well the bad press around the problem is nobody ever says anything if a brilliant job's being done. When something don't work, that people start shouting. And there's also the standards that were brought in. A lot of the heat pumps that don't work, that people moaned about, were installed to a standard that actually had, in my opinion, lower temperatures than what you'd need to have in an house. Just cutting back to the whole overall thing of getting everything run efficiently, my final comment to everybody is learn what's installed in your building and how to use it. Get building manuals out and read them, because if you don't know what's in there at minute, then you're never going to get it right. You will find in most manuals there will be the settings or the design for that building, whether it be, especially if you've got a large office block or something in there, everything that it's designed to run out. So if you took a large building, this system designed to keep 23 degrees in summer when it's 30 degrees outside, as long as the air handler's delivering air in at 18, all that information will be there. If all that isn't set up to do that, then you could be just chucking money down drain and making it, that space really uncomfortable. Get yourself stuck in. Don't just leave it to somebody else. If you own a building, get your edit manuals and get them read.
Thank you both again for sharing your expertise, sharing your knowledge, and helping us along on our journey towards net zero. We'll see you next time. Thank you.
Thank you.
So this was the tip of the iceberg from the Institute of Refrigeration, and I'm Miriam Rodway. We hope you're enjoying our podcasts. Please like and share and follow the podcast, and join us on the next edition. Thank you.